Nuclear energy for dose and risk. So ionizing radiation, and nuclear radiation is ionizing, damages cells and it can cause cancer. So exactly how dangerous is it? How do we quantify the risk? If we're going to send people to work in nuclear power stations, we want to know what risk they are taking. So how do we quantify risk? Well, to do that, we have to define, first of all, dose. Now, there's two units for dose. There's Gray and sieverts. If we have a look at Grays first, a Gray is basically a joule per kilogram. If you have 1 kilogram of body tissue and it absorbs 1 joule of energy, then that is a dose of 1 Gray. So 1 Gray is 1 joule per kilogram. The amount of energy absorbed will depend on the activity of the source, the time of exposure, and the energy of the particles. Now, there are other factors which will affect how dangerous it is. The type of tissue. It's interesting that cells that renew themselves more rapidly, such as skin cells, or if you're a gentleman, the ones between your legs, they multiply rapidly and they are more susceptible. And this is actually how radiotherapy works, because cancer cells are more susceptible as well. So we blast cancer cells with nuclear radiation, and ironically, that's a good way of killing them. The other thing is the type of radiation. Types of radiation are more dangerous than others. Alpha radiation is very dangerous because its damage is more concentrated. Its ion trail is very, very dense. Its damage is much, much more localized. And because of that, the chances of it causing cancer is much greater than beta or gamma. Okay, and we take these factors into account by multiplying the dose in Gray by something called a quality factor. Here are some quality factors, and you'll see that the alpha particles and fast neutrons are the most dangerous, whereas photons, such as a gamma photon, and beta particles are much less dangerous. So, how dangerous is 1 sievert? Well, there's been various estimations. Basically, the risk of cancer due to an exposure of 1 sievert has been estimated at 5%. So if you are exposed to 1 sievert of radiation, there's a 1 in 20 chance that it will cause you cancer. Here are some doses, not in sieverts, but in millisieverts. If you have a dental X-ray, that's 0.01 millisieverts or 10 microsieverts. And then you'll see read the table for yourself. Natural background radiation is 2 millisieverts per year. The people who lived at, is it Pripyat or something near Chernobyl, they got a dose of 350 millisieverts. If you get a dose of 3,000 millisieverts or 3 sieverts, then you'll probably be dead in a couple of weeks. The last one's interesting. If you go into space without any shielding for a week, for example, if you go to the moon and back, 70,000 millisieverts, 70 sieverts. Shielding is very important if you go into space. Remember that. Okay. Talking about the risk of cancer, saying that a dose of 1 sievert would make you very, very ill. It would destroy a lot of your cells without giving you cancer. You would have radiation poisoning, which you could recover from if you don't die, but it would make you very, very ill. Here's a question you can have a go at. Have a read of it, and I'll show you the answer in 3, 2, 1. There you go. And it hasn't happened to me, by the way. I've done a couple of trips and this hasn't happened yet.